Of normally distributed random variables is also normally distributed. This is key. Any linear combination of normally distributed random variables is also normally distributed. Now, what is a linear combination? A linear combination involves adding and subtracting variables like x plus y, x plus x, x minus y, or multiplying them by a number like 2x and adding something, 2x plus 5. So those are the things that we looked at in the last lesson, like the taxi cab company. Like it costs, you have to pay $5 plus $2 times every mile. So 5 plus 2x is a linear combination of a normally distributed random variable. When we were adding the variables, like two insurance policies, when we went over questions, that's a linear combination. Okay? So, for example, if x and y are normally distributed, then here x plus y, x minus y, 2x plus 3y are also normally distributed. So, we have men's weights in pounds are normally distributed with a, what's that first number represent?
Mean.
Mean. So that first number represents the mean, and the second number represents the what? Standard deviation. Okay, if you don't know that yet, you have really literally not read your book at all. Or watched me do anything.
Or not been awake.
Okay, or have not been awake, yes. Women's weights are normally distributed with a, what's with the 165? Mean. And 43 is the standard deviation. And we're assuming this would be in pounds. It says in pounds. And a man and a woman are selected at random. So here's what we're doing. We have two normally distributed variables. X is a man's weight, Y is a woman's weight. Or we could call them whatever we want to. We don't need to call them X and Y. You can call them M and W if you want to. In fact, that's what we're going to do. So we would like to select a man and a woman, and we want to know what is the probability that the sum of their weights is at least 300 pounds. So what we have to do first is we have to define our random variable. So the first thing we have to do is define our new random variable. Okay, we have a definition of our two individual random variables, men's weights, women's weights, but we would like to define the new variable, which is the sum of their weights. Okay, so this, I'm going to call this, we'll call this men is approximately normally distributed at 197, 47, and women is approximately normally distributed at 165, 43. So these are our individual random variables right now, and we would like to combine them into a new random variable called M plus W. Men's weights plus a woman's weight. Because we are going to select a man and a woman, and it says what is the probability that the sum, see the key word, sum of their weights is 300 pounds. That's how I know to add. So, at least 300 pounds. Now, I'm not worried about that at least 300 pounds yet. All I'm worried about is defining this random variable. Okay? We need to come up with this random variable, its mean and its standard deviation. So the mean, okay, so the mean of M plus W would simply be the mean of M plus the mean of W. Well, what's the mean of the men's weights? 197. Plus the women's weights? 165. So another way, instead of writing out all those words, you could write the mean of M plus W. Or you could define a new random variable X is equal to M plus W. Okay, so the mean of M plus W would be what? What's the mean weight of a man and a woman? 362 pounds. Okay, so there's the mean that we need. And now what else do we need to find? Standard deviation. So the standard deviation of men's weights plus women's weights would be the variance of men's weights. How do you find the variance of men's weights?
Double square it.
47 squared. You don't double square it, no.
I was going to say double it.
Okay. Plus the variance of women's weights. What's the variance of women's weights? 43 squared. And then you square root the whole thing. Variance, add the variances, then square root. So you need to calculate that for me. Tell me what the standard deviation of men's plus women's weights is. 63.7 pounds. Okay. So now here's what we have. We have just defined our new random variable. Our new random variable, I'm going to write it up here, okay? Men plus women is approximately normally distributed with a mean of what? 362 pounds and a standard deviation of 63.7. This is the variable I am going to use to answer the probability question. What is the probability that the sum of their weights is at least 300 pounds? So here's what we did. To this point right here, everything we've done so far is combining random variables. We had two random variables that were normally distributed, and we put them together using our rules from last time. Now we're going to use this new rule that we wrote to find a probability, like we've done back in chapter 6. So now we're looking to find the probability that m plus w, my new random variable m plus w, is what? It says at least 300 pounds. What does at least mean? Greater than or equal to 300 pounds. Okay, hold on. What should we draw for our probability question?
A normal pie.
We better draw a normal curve for our m plus w. So the normal curve, I'm going to draw it here so I can make it nice and big. So I'm going to draw it here. This is my m plus w, approximately normally distributed with a mean of 362 and a standard deviation of 63.7. So I've got 362 pounds is my mean weight, and then you need to help me with the standard deviations.
First one. I got the bottom. Oh my gosh, what is it? Did you get the bottom? Yeah.
Okay, just go.
Oh, 170.9,
170.9,
234.6, and 298.3. And then one above is 424.7, 487.4, 550.1.
Okay, and how did you get these values? What did you do?
Added the standard deviation 3 times.
Yeah, so you started with 362, and to get this you added that number right there, the standard deviation. Then to get this number, you took that number and added the standard deviation again. What is it again?
87.
Okay. All right, so here's our normal curve. Now, we need to shade in. This is for part
There's 425.
0.7,
Oh, I wrote down.
which would make what?
489.4.
Okay. It's okay. We're fixing it.
Same.
And then the last one is what?
553.
553.1. Okay, it's all fixed. We're okay.
Professor will let that happen.
Yeah, no, I don't know.
Okay. Okay, so now we are looking for, we have to shade the section we want to tell us how to use our NCDF, right? So, where's 300? Isn't it like about right there? No. We want to find, everyone pay attention, up here. The probability that it's greater than or equal to 300. So we find 300 on this thing we just made. There's 300 about right there. And we want it to be greater than that. So this is the section we're looking at. So, can I use NCDF? Okay. So this is a must. You have to draw these pictures. So then we're doing NCDF. What is the lower bound? 300 is the lower bound. That's on the left. The lower bound is on the left of the shaded area. That's why you draw the pictures. What is the upper bound? 9999. You need at least 4 nines. Okay, what comes next? The mean. So this is lower bound, upper bound. This is the mean and standard deviation of my new distribution. What is the mean? 362. What is the standard deviation? 63.7. And then you hit enter.
0.8.
And you get 4 decimal places. 0.8348, which is 83.5%. Does that picture look like I shaded about 85%? You can always do a double check. Does that look like about 85%?
Yeah.
It does, because this first standard deviation mark, what percent is in that little section right there? 34, normal CDF. He might not if he hasn't really been doing his homework.
Yeah.
Okay, remember okay, this is review. Trevor,
Yeah.
where you're sitting is kind of causing you to not pay attention or be loud.
Be loud?
I don't
feel
know.
so far away.
I know.
Does
You could
every
maybe
class-
move closer.
So
I
you're
don't know
always
if that would
focused.
help you. Okay. So, what percent of data values are within one standard deviation?
64.
No, 68. So what's on each side? Hey guys, this is part of the problem. Just let people talk and don't, just let's move forward, okay, forward. So what percent's in each half? 34%. So if you're looking to see if your answer of 84, about 83.5% is reasonable, what percent's in this half? 50, and this is about 35, and yours is a little less than that, so is our probability very reasonable? Yes. Okay. So now let's move on to the next question. What is the probability that the woman is heavier than the man? Okay. So, probability that the woman is heavier than the man. Guess what? We have to define our new variable. Have you guys learned this before?
Yeah.
You have? Because you're acting like you have with all the conversation going on. So, okay, so what is the probability that the woman is heavier than the man? We still have to define our new variable. It's not the same variable we had in the last one. How do you know if a man is heavier than a woman? What linear combination of the man and the woman from up above, what linear combination of these two variables will tell us if the woman is heavier than the man? Add, subtract, multiply, like woman weight by 2. What do? How would you figure out if the man is heavier than the woman? Okay. Wouldn't you subtract? Don't you need to know the difference in the weights in order to see if the man is heavier than the woman? Okay. Now, I can show you a way to, basically your new variable, we can call it X, is the man minus the woman's weights, or it could be the woman minus the man. That's our new variable. If a woman is heavier, basically, here's one way to look at it. You could say, if the woman is heavier, wouldn't the women's weights be greater than the men's weights? Okay, this is reasoning it out. So if I wanted a linear combination, this is not a linear combination. Remember up at the top, any linear combination of normally distributed random variables is also normally distributed. Okay? This is not a linear combination, it's an inequality. So I need to change it to a linear combination. Linear combination is adding or subtracting and multiplying by constants. So, if I move the women's weight over to the other side, what math operation will move it? Subtraction. It's positive here. I subtract it to move it to the other side. So if I minus W from both sides, basically it would be man minus woman. I mean, that's how you deal with it, okay? But you have to be able to think through what linear combination would tell us that a man or woman is heavier than a man. So which one do you want to do? Man minus woman or woman minus man? Man minus woman. So this is going to be our random variable. Okay, now how do I know if the woman is heavier than the man? What will the value of this be? It'll be negative, then the woman is heavier than the man. Okay? All right. And basically that makes this easy. So what number would have been left over here if I moved it? 0. So this would be saying the man minus woman's weight is less than 0. You see how that whole inequality? That actually works out and says the difference between man and woman is less than 0. That would tell me that the woman is heavier. If you subtract a man's weight minus a woman's weight, you get a negative, that means the woman was heavier. Okay, now we have to define our new variable exactly the same way we did up here with this work. So define our new random variable. So we need to find the mean. So we need to find the mean of men minus women's weights, which is just the difference in men's minus women's mean. It's that simple. To find the expected value, the expected mean of the difference, we just subtract the means. So what was the mean of men's weights? 197. minus the mean of women's weights,